Congratulations, you made it to the last lesson in chapter 1. This is Ms. Gill, and we are going to talk about piecewise functions today. So we are going to graph and we are going to write piecewise functions. Piecewise functions are exactly what they sound like, pieces of functions. Okay, so it's still functions, they are just separated. So you have an example right here where you see this is a close or open circle. An open circle, you can barely see that, but it is open. So you have an open circle and this graph is going this way, and you have a closed circle and this graph is here. So what happens is it's going from negative infinity, it stops and it has a breaking point, and then it picks back up here and goes to infinity forever. So because of this, we have to deal with different situations than we have. All right, so again, with your greater than or less than, so if you have a greater than or less than, you have an open circle. I guess I could zoom back out now. All right, if you have greater than or equal to or less than or equal to, then you're going to have a closed circle. So just like normal, like we did in lesson 4, nothing different there. All right, so let's evaluate. So what does evaluate mean? In case you forgot, it just means find the answer, solve it. All right, so they're giving us these two functions. This is function 3x plus 1, but this function only exists when x is less than 2. Then we have the function x minus 5, but this function only exists when x is greater than or equal to 2. So we are going to evaluate what a would be, so x equals 2, and what b would be, so x equals negative 1/3. So we're looking at this a is x equals 2. So you got to look at these. Which category does 2 fall into? So this one is less than 2, but we have the equal sign. So we're going to go with the x minus 5 function. All right, so we're going to use that one. So what does that mean? We're going to take this value of 2 and we're going to plug it in for x. And if you take 2 minus 5, you should get negative 3. So f of 2 is equal to negative 3. So this was part A. I think I forgot to write that. I did. All right, so let's look at part B. So part B, when x is negative 1/3, so which category does that fall into? Well, we know negative numbers aren't going to be greater than or equal to 2, so it has to go into this one. So we're going to take that function, 3x plus 1, and we're going to substitute in negative 1/3 for x. So in the x spot, we're going to put in negative 1/3. Just because it's a fraction, don't start getting scared, because this is an easy fraction. 1/3 of 3 is just 1. You could also look at it as 3 times negative 1 is negative 3. Negative 3 divided by 3 gives you negative 1. So we got negative 1 plus 1, and that equals 0. So f of negative 1/3 is equal to 0. So you may ask yourself, Ms. Gill, that was pretty easy. I feel like that's stuff we did in middle school. It can't be that easy. It is. That part is that easy. All right, so now we're going to graph it. Okay, so we're going to graph the piece. This can be a little tricky. All right, it can be a little tricky because we're used to graphing linear functions. We should be able to without the calculator. There is a piecewise function in the calculator, but I'm actually not that familiar with it because I personally don't find this too challenging to where I need the calculator. But if you would like to explore that with me, I'm sure we could figure it out. So because these are linear, we're going to use y equals mx plus b. Sorry, I didn't realize it was too high. Where b is your y-intercept and m is your slope. Okay, so first off, we're going to start with this very first one. It says when x is less than 0. So where is x equal to 0? Right here on the y-axis. So that means that this graph is not going to exist over here. It's only going to exist over there. So how do we figure out where it is? Well, we may need to use a little help over here first. Okay, so here's what I mean. Well, if we have negative x minus 4, we know this is our y-intercept, and if there is none, this is our slope. So now we know that our line should be going like this. It should be decreasing. Okay? We also know we should have what type of circle. If you said opened, you are correct. So 0 and our y-intercept go hand in hand. So 1, 2, 3, 4. So we're going to put an open circle at negative 4 because that's when x is 0. Now, remember we have negative slope. So typically we would go down 1 over 1, down 1 over 1. But remember our graph doesn't exist over here. So we're going to go backwards. So left 1, up 1. So instead of down 1 over 1, we're going backwards, right? So this is our graph is going this way. So we're just going to go ahead and draw an arrow. It should go through the corner of every box and hopefully not look as wobbly as mine. All right, so this is negative x minus 4. All right, so now our function is x if x is greater than or equal to 0. So this might seem a little tricky, okay? Because you're like, Ms. Gill, there's no y-intercept, right? Well, think about like this. If there's none, there's a 0, right? So 0 is where your graph intersects the x-axis, and we know it does include 0. So we can put a closed circle there. And then we know our slope is 1. So what does that mean? Up 1 over 1, up 1 over 1, up 1 over 1. So we can go through the corner of all of the boxes. And this is the equation of x, which is actually your parent function for the linear function. It's just doesn't extend this way, okay? So now they want us to describe the domain, the range, and the end behavior. All right, so because this is a closed circle and this part does include 0, it kind of cancels this out with the domain. So what I mean is, before, when we had a graph going this way forever and a graph going that way forever, we said the domain was all real numbers. Well, if these did not connect here, we would say something different, like x is less than this or x is greater than that. But because this is a closed circle and 0 is included, even though it's not included here, it is included here, that means that 0 does become part of the domain. So in this case, the domain is still all real numbers. Now, if you had a situation where they were separate, like say this one didn't start until 2, then the domain wouldn't be all real numbers. It would be values less than 0 and values greater than 2. So just keep that in mind if you come across that. So our range. All right, our range is, how does the graph exist this way, right? Well, if we look at the graph, there is no point of my graph below this point. Do you agree? Hopefully you said, yes, Ms. Gill, I do agree. So that means that that is the lowest y value. So we're going to start off and say y, and what is that value? Negative 4. So in order to write our range, we're going to say, is it greater than or less than? Now, remember, because it's open circle, we're not going to put or equal to. If it was a closed circle, we would put or equal to. But because it's an open circle and it includes all y values going up this way, we are going to say only when y is greater than negative 4. Or if you want to put it in interval notation, you would put negative 4 to infinity. All right, so now we got to do end behavior. So what is the end behavior? All right, so we're looking at where is this end going, right? Where is this end going? So this is in quadrant 2, where our x values are negative, our y values are positive. So as y approaches positive infinity, x approaches negative infinity. Hopefully you remember this from the graphing characteristics paper that we did in class that first week of school. If you have lost that paper, please come see me for a new one. Y'all and the paper losers in the world. All right, so that's this side. So where is this side going? Well, it's going this way forever, where our x values are positive and our y values are also positive. So we would say as y approaches positive infinity. Again, this time x is approaching positive infinity. Okay? If you have some examples you want to look at domain and range, maybe you want to look at just some sample graphs and just talk about domain and range, just make a note, because I want to make sure you guys fully understand what the domain and range entails, because it's really not a hard concept, it's just an easily misunderstood concept. All right, moving on to the next question. I don't know if I mentioned this, but this is an honored standard in this chapter. So it's just one of those extra lessons that we have to do. So if you have a friend in standard class, just know that they will have no idea what you're talking about if you talk about a piecewise function. All right, so now we are going to write one. So far we've looked at evaluating one. We've taken one from the equation to the graph, and we've graphed it. Now we're going to take it from the graph and write an equation. So the way I find this easiest is to look at, I like to work backwards. You're welcome to work any way you want, okay? So we have two functions. We have one when it's less than positive 3, and one positive 3. Ma'am, that is 0. Oh, dear Jesus. That is when x is 0. It is positive 3 on the y, but that's when x is 0. So we're looking at when x is less than 0, and then this one is a closed circle, so we're again going to look at when x is greater than or equal to 0. So we're going to have two functions. And you're going to draw this. I always say forehead, nose, chin if you don't know how to draw it. Forehead, nose, chin. I don't know. Somebody taught me that at some point. All right, so we know this first one is going to be when x is less than 0 because it's not or equal to. So go ahead and leave space because we still need to write the functions. I just think we could go ahead and write what we know so far. So we know then x is greater than or equal to 0. So this is going to be our first function. So how do we figure out what the graph is? Or the equation? Because we're going to use slope-intercept form, right? Again, we're going to use y equals mx plus b, where b is our y-intercept, m is our slope. So what is our y-intercept? 3. So we got a plus 3. So now we got to figure out what our slope is. So the graph is not going this way. Remember, we read left to right. So technically the graph is going this way. So it is increasing. So your slope is positive. So you need to find 2 points on the line you can clearly see. Well, I can clearly see those two. So if I go up 1 over 1, that looks like the slope is 1. You could test it with this one. We definitely know is there. If you go up 2 over 2, 2 divided by 2 is also 1. So we know in this case our slope is equal to 1. So if we have 1 for our slope, it is not necessary. Remember, if there is none, there is 1. If it makes you feel happy to put a 1 right there just for time, go for it. But I'm erasing it. Oh, well, now it's ugly erased. Thanks for making me put that there. All right, moving on. So we're going to do the same thing. What is our y-intercept here? If you said -1, great job. So we're going to come over here. We're going to put a -1 because that's our y-intercept. All right, what is our slope? Find 2 points we can clearly see. I see one there. I see one here. We're going up 2 over 1. Up 2 over 1. So our slope in this case is positive 2. Again, we read left to right, so it is increasing. So our slope is positive. So we have 2x minus 1. So that is all that this lesson entails. Notice that your practice questions are listed here. You are welcome to try them at home. I'm trying to figure out why I put the graphs right here. I made this last year. I just didn't feel like remaking it. Maybe because you could practice graphing. I would do that. So I would take these and I would practice, because I'm assuming that's why I put these here, to practice graphing them. So you're going to evaluate these, or you're going to evaluate the function. So number 1, you're going to evaluate here. But to practice, so make this the graph for number 1 and the graph for number 2, and just do number 1 for that. I don't know. I don't remember my logic last time. This is a question. You could call this number 3. I remember this one being weird now that I'm looking at it. So if you go to do this one and it's weird because the y-intercept is kind of hard to see, I think. So give it your best effort, all right? I'll let you know. I just remember this one was a little hard. It was a little weird. So if this one trips you up, please don't stress, okay? We'll make that number 4. This one you should be able to definitely do. These you should be able to definitely graph. So if you have questions, again, you're welcome to do this part in class, so that way if you come across an issue and you need a quick help, you can ask me, because that is the intention, is to do this in class. However, if you're a couple lessons behind, it might benefit you to go ahead and do this practice real quick. All right, guys, so again, you have questions, please come to class prepared to ask them, and I will see you in class.